Okay. Okay, so I've started the recording. So anything that you say or write at this point will go down for posterity. Okay, I'm going to go back to the presentation. Okay, so the topic today is going to focus on your lab reports. I'm going to go over the expectations for your lab reports, what needs to be included. I'll show you some examples of really nice lab reports that have been written in the past so that you can see what those look like. And I'll go over specifically also some information about this special lab report that you're going to write in the style of a journal article. And we'll talk about also some stylistic considerations for scientific writing, how you can make your writing clear, precise, and concise, also not too long, or not longer than it needs to be. Okay, so first I'll talk a little bit about short reports. So for every single one of your lab reports, except for one special one, you're going to write a lab report in the style of a short report. And basically, let me change my cursor to a, can I get a laser pointer? Yeah, bottom one. Oops, laser color red. Oh, laser pointer, this one. Okay, yeah, now I got a laser pointer. Okay, good. So yeah, so what does a short report look like? So you need to include the following elements. These are listed in the course syllabus, in addition to this PowerPoint presentation. I'll put this presentation also online after we get done this evening. So you need the title, date, your name. If you had a lab partner, put the names of any lab partners. You need to have a brief statement of the purpose of the experiment. This can be very brief, just 1 or 2 sentences. What did you measure? What did you do? You need to have your data presented either in the format probably of a table or a graph. Then you need to have a separate section where you do calculations and analysis of your data, including error analysis and error propagation. You need to then have a separate section where you present the final result, probably in the form of a table, in some cases maybe in the form of a graph. Then you need to have a discussion section where in most cases you're going to be talking about how reliable are the are the results that you came up with. Why can you trust it or not trust it? Maybe you want to compare it to results in the literature. Maybe you want to discuss what might have gone wrong, how the experiment could have been improved, what might be done to follow up if there's something that remains unclear. And then you're going to include at least 2 references that need to be cited, not including your lab manual. And finally, you need to include a photocopy of the relevant pages from your lab notebook showing the raw data. Okay, and just to remind you, so the syllabus that I've given to the TAs that they're going to use in order to grade the lab reports, or I'm sorry, the rubric, I should say, is given here, and it's also printed in the syllabus. So there's a certain number of points assigned to each section. So please make sure that you include each of the sections as listed here. Otherwise, your TA won't be able to give you any of the points for that section. Okay. Okay, so I'm going to show just an example of a report so that you can see what this looks like. Okay. Okay, this is a lab report from 3107, but it has the same format as lab reports in 3108. Okay, I think you should be able to see this. Hopefully it's big enough. Okay, so you include the title of the experiment, the date, your name, the purpose of the experiment. This can be just 1 or 2 sentences. So in this case, this was the experiment determining the heat of formation of naphthalene by bomb calorimetry. And so the purpose is stated in a concise sentence. Then you want to have the raw data essentially from your experiment. So in this experiment, basically you measure out a sample, you put it in the bomb calorimetry, you combust it, and you measure a temperature rise. And so that's the raw data that you want to report. So for the calibration experiment using benzoic acid, the student wrote the mass of the benzoic acid, also the mass of the ignition wire that was used, because that also contributes to the temperature rise, and that has to be corrected for. Then there's a table where the student wrote down the values from his or her lab notebook, which is basically a measurement of temperature versus time during the experiment. And that continues on to the next page. Notice that the tables have a short title above the table, and also the units are given. So time is measured in minutes, temperature is measured in degrees Celsius. Okay, the second part of the experiment involved combustion of naphthalene. So there's a separate table for that portion, and then a separate temperature versus time table. Okay, and then trial 2. Okay, so the student repeated the experiment, and then the data is shown again in graphical format, because this is the format that was used in order to determine graphically the temperature rise, which was used to determine the heat of combustion. Okay, so the figure has a title, it's figure 1, and it's the thermogram for benzoic acid. Note that the axes are labeled appropriately, including units, so the time in minutes, temperature in degrees Celsius. Okay, so that's basically the data section. Then for the calculations, so the calculation portion of the lab report does not necessarily have to be typed. If it's easier for you to do it, handwritten calculations, that's also okay. But your TAs will appreciate it very much if you do type the remaining sections of the lab report, right? So the sections other than the calculation section. Okay, so here the student wrote how they determined the temperature rise, right, by taking the difference of these 2 measured temperatures. And they explain in a sentence how they obtained the error in this number, which was basically they fit this portion of the data to a linear fit, and they fit this portion of the data to a linear fit, and then based on the uncertainty in the fit parameters, they obtained an uncertainty in the temperature rise. Okay. So then here's one part where the TA made a comment that the units are missing. So make sure when you report a number, it always has units. So this is the uncertainty in the temperature rise. So it should have, in this case, units of degrees Celsius. Okay, the student then explained how they propagated the error. And then they explain how they calculate the, so for the calibration portion of the experiment, they explain how they calculated the heat capacity of the calorimeter and the uncertainty in the heat capacity of the calorimeter, right? The calculations are all shown explicitly. Okay, and then in the second portion of the experiment, basically they measured the heat of combustion of naphthalene and determined based on that number its heat of formation. And so the calculations for the total energy release, right? Internal energy release, internal energy change is given here. And then the heat of combustion, or sorry, the enthalpy of reaction, enthalpy of combustion is calculated according to this formula here. So they show the calculation, and then they show the uncertainty, how they get the uncertainty that's calculated explicitly. Okay, and so that's basically the end result. And then the heat of reaction is used to obtain a heat of formation of naphthalene. Okay, so then there's a separate section, and please do make sure that you include this as a separate section, right? Because it has its own place in the rubric where you present the final result, right? So, maybe this number is included at the end of your calculation, but your TA doesn't want to have to do a, search through your calculations in order to find the final values that you're reporting. Those should be presented probably in a table in this next section, which is the presentation of numerical results. And so the main results of the experiment are given here: the heat capacity of the calorimeter, the change in internal energy due to the combustion reaction, the enthalpy of combustion reaction, and then the final result, which is the heat of formation of naphthalene. And if I were grading this lab report, I probably would have taken off a couple points here because the student did not propagate the error in the heat of reaction to determine the error, right? The uncertainty in the heat of formation. That should also be included here. Okay. The final section, or almost final section, is the discussion section. And this can also be pretty brief in most of these lab reports. So here you can see it's just one paragraph. That's enough. That's all you need to write. And in the discussion, you probably want to repeat the final result, the most important result, and you want to talk about its validity. So in this case, the student compared their result with the literature value. So the literature value is 717 kilojoules per mole. The value they got was 727 kilojoules per mole. So it's pretty similar, but it's slightly outside the error bound. And so they discussed a possible reason why that might be. And they said, well, the literature value was obtained in an experiment that was performed at 25 degrees Celsius, but actually in our experiment, the temperature was like 22 degrees Celsius. So that could be one cause of the discrepancy. Okay. You want to include at least 2 references other than the lab manual. So in this case, the student gave references to basically the literature values for the heats of formation of benzoic acid and naphthalene. And then finally, in the appendix, you should put a basically a photocopy of the relevant pages of your lab notebook so that the TA can make sure that they can see where everything came from when they're looking through your lab report. Okay, any questions about that? Yeah. Yeah, if you have a reference, yeah, the best practice is to refer, yeah, have also a citation in the text. Yeah. That may or may not have been the case in this lab report, but that is the best practice. Yeah. That's what I would recommend doing. Yeah, you can report the error as one decimal place. That may have been the case. Yeah, the TA in this case did not take off for it, but they would be entitled to take off a point or two for that because that is, clearly what explicitly, the instructions that we gave you. Okay. So yeah, probably that's too many, way more decimal places than are actually significant. Okay. Yeah, you're correct. Thank you for pointing that out. Let me see, are there any questions from the Zoom? Let me check Zoom. There is one thing in the chat. NIST is a great reference if anyone wanted an example. Okay. Thank you. Okay, I'm going to go back to my presentation. Okay, so in this course, you're going to do one lab report that's going to be in the style of a journal paper. So the purpose of this is to give you some practice, sort of doing some real technical scientific writing and get used to writing in this style. And the lab report that you're going to do that for is the one on inversion of sucrose. And let me get my laser pointer back. Yeah, there we go. Yeah, so you might want to just, write yourself a reminder, look up on your calendar or look up on your schedule, what's the week where I'm doing inversion of sucrose, and just put yourself a reminder on your calendar. This is the week that I need to be writing a journal style lab report, because if you turn in a short report instead of a journal style lab report, you're going to have points taken off for that. Okay, so the rubric is given here. So some of the elements are the same as for the short reports, but there's also some additional elements that need to be included in this special journal style lab report. Okay, so you need to include title, date of experiment, your name. If you worked with anyone, include their name. You're going to include an abstract, and I'll go over what needs to go into all these sections in the following slides. So abstract, which is basically a summary of what you did and including the main result. You need to write an introduction. Just like in the short report, you need to write a statement of what is the purpose of the experiment. In this particular lab report, you'll also have an experimental section where you outline the procedure that you followed. You're going to have a results section, data analysis and discussion sections, a conclusion, and then again, you're going to include references and an appendix. Okay, so let's go over what should be included in all of these sections. Okay, so what is an abstract? An abstract is basically the scientist's version of a TLDR, right? So the abstract is extremely important because when you're working as a scientist, you have to decide, sometimes you're looking for a specific piece of information, or you're trying to understand a particular area, and you need to decide, do I need to read this paper or not in my research, right? In order to get the knowledge that I need. And so the abstract should basically let you know what's included in this paper, what did they do, what are the main results? And, if I think that that's going to be relevant after reading the abstract, then I can spend more time and look through the whole paper. Right? So it's very important to write a good abstract. It's short, typically 50 to 100 words. You want to briefly describe what was measured and how you measured it. You want to summarize the main results and any significant conclusions that arose out of your experiment. And you want to report the final numerical result. If the purpose of your experiment, for example, was to measure a particular rate constant, then you want to say, we measured a rate constant of, X number of, moles per liter second, plus or minus X, right? So give the numerical result and its uncertainty. Okay. I don't see any questions, so I'll keep going. Okay, so the introduction section. This is something that I think, if you haven't had to write an introduction in the style of a journal article, some people are a little bit confused. What exactly should I include here? So the purpose of the introduction is basically to introduce the topic, draw the reader in a little bit, and give the relevant background information. So you want to talk a little bit about what's been done before, where do these ideas come from that we're using in this paper, and also you want to motivate your work. So you want to explain why is this particular topic interesting and important. So for example, in the inversion of sucrose experiment, obviously sucrose is an extremely important molecule in biochemistry and in the human body. And so you might want to mention why is this molecule so important? And you want to look at what is the reaction that you're studying, and maybe why is this reaction relevant in biochemistry, right? So the breakdown of sucrose into glucose and fructose, that's basically what you're studying in this reaction, right? And that has a biological relevance. Okay, so that's the type of information that you can include here. So you're going to describe the purpose of the experiment and its relevance to understanding some chemical or physical process. Okay, you're going to include some background information. So in the case of the inversion of sucrose, you might want to include a little bit of information about what is polarimetry, what it's used for, how it works. Yeah, you can include references to previous work on which the experiment is based. And you want to explain any underlying theories that the reader needs to know in order to understand the experiment. So you might want to explain how polarimetry can be used in order to determine an enantiomeric excess, for example. Okay. Okay, next is the procedure section. You want to describe how you prepared the sample that you're looking at. You want to describe the apparatus that you used to make measurements on the sample. And you want to explain how you did all this. So how was the apparatus used to obtain the results? And your goal in writing a procedure section is basically that another scientist with basic training in chemistry should be able to read the procedure section, and based on the information in the procedure section, they should in principle be able to reproduce the results that you got. Okay, so if you don't have enough information for someone to be able to reproduce your results, then your procedure section is lacking. You need to include all the information necessary. Okay, but you don't need to include extra information. So if things are, details that are too specific, don't need to be included. We'll look at some examples a little bit later. Okay, the next section is the results section. This is where you're going to present all of the data that you collected. These should be organized so that the reader can understand. So you're going to use either tables or graphs to represent the data. You can report any relevant observations. You can describe trends in the data. Please don't draw your graphs by hand. You can plot them using software such as, we showed how to do this in Excel, for example. Okay, so the next section is data analysis. So make sure that the presentation of the raw observations is separate from the analysis of those observations. So you want to describe the method that you use to analyze the data, right? How did you do these calculations? How did you come up with the final results that you're reporting? You want to provide sample calculations detailing all the steps. If your result involved using a fit to a theoretical equation, you want to show a graph of the data with the fit. So usually you want to include your raw data as markers on the graph, and then you want to include the fit as a curve or as a line plot going hopefully through the data points. You want to show how the errors were calculated or how any error propagation was done. And if you made repeated measurements of values, you want to calculate the uncertainty, and you want to represent the uncertainty in the average value that you're plotting using error bars. So you should put error bars on the points in your graphs. Okay, next is the discussion section. The discussion should include an interpretation of the data based on your analysis and on a comparison of the results to literature values, just as we saw in the short report. You also want to explain any sources of experimental error that could have led to deviations from the expected theoretical or literature values. And then finally, you want to have a conclusion section. So here's where you, once again, summarize what is the main finding of your experiment. You want to explain whether your experiment was a success or failure. And here you could include a little bit more speculative information, like you could suggest an improvement for the experiment, or if you're not sure why your value doesn't agree with the literature value, then you could suggest additional experiments that could be done to find out what the problem would be, or what the problem could have been. Okay. And then finally, also, you're going to include references. The question earlier was, do you need to cite the references in the report? And the answer is yes, please do. So you're going to include a numbered list of references at the end of the report. And when you refer to those references in the text, in the body of your report, you're going to cite the references. There's two ways to do that. Either one is fine. You can either use a numerical superscript, or you can use a number in brackets to refer to the reference list. Okay, and we want you to follow the ACS format for references. And let me quickly, actually, before I show you an example, I'll just show you information about the ACS format. So here's what it looks like. So if you're citing a journal article, you need to give the author's last name, comma, initials. Then you need to give the name of the journal in italics. You can either use an abbreviated journal title or the full journal title, either is acceptable. The year should be in bold. The volume number should be in italics, and the first page that the article starts on should then be listed last in plain font. Okay. If you're citing a book chapter or an entire book, you give the names of the authors, again, last name, comma, initials, or I should say family name, comma, initials. So if it's a chapter in a book, you want to give the name of the chapter and then the name of the book in italics. If there's a book editor, you give that after the title, and then you give the publication information. If you're citing the entire book, it's a little bit simpler. You just give the authors, title of the book, and then the publisher information. Okay, so there's more information that's available at these links, so you can check those out. Okay, I'll show you just an example of a nice lab report that got a good grade from a previous semester. Okay, let me make this a little bit bigger. Okay, I think that should be big enough. Are there any questions at this point? Let me check. Nothing in the chat that I can see. Okay, so notice this lab report did not receive a perfect score because the appendix was not attached, right? So the section where you photocopy the pages out of your lab notebook. So that's just a reminder. Please make sure you include all the sections that are in the rubric in the syllabus. Otherwise, you won't get credit for those sections. Okay, so there's title, name, date, and then here's an abstract. The abstract doesn't need to be long, but this is a really nice abstract. It basically, it says what's the purpose of this experiment. What did we basically do? So we did a concentration-based calibration curve of sucrose, and then we did a kinetic study to look at the catalytic cleavage of sucrose using a strong acid. There's one sentence about how the data was analyzed, basically, and then they report the final result. So the purpose of this experiment was to measure a rate constant, and so the value of that rate constant in units of per second is given with its stated uncertainty. Okay. So then there's an introduction section. So basically the student introduced here the topic of polarimetry. They included a nice figure showing basically what the experiment looks like. That's not a requirement, but I think it's nice. Of course, they refer to the figure in the text. So they say what's included in the figure. And they give a citation where the figure came from, and another citation here to reference to, which is some background information about polarimetry, basically. Okay, so then they also give some background information about the system that they're studying, which involves the catalytic cleavage of sucrose. They include a figure illustrating the chemical reaction, showing all of the stereochemistry. And then finally, they give a little bit of theoretical background about how the results are interpreted. So they give the fundamental equations that you need, the definition of alpha infinity, and then also an equation of how the rate constants in this type of experiment are related, how they can be defined. Okay. So the next section outlines the procedure. They explain how they used a polarimetry, how they obtain the background, basically the 0 point. They explain the procedure, and so in your lab manual, the procedure is given as sort of a list, 1, 2, 3, but in your lab report, you need to put it in prose. So you need to have text that the reader can read and follow exactly what you did. Okay, so they explain the procedure, exactly how they prepared the sample by basically dissolving sucrose in water. They include a table to avoid having to put everything in this paragraph. That would be tedious. Then they explained how they measured the polarization and how they used that to look at the kinetics, right? So they're measuring polarization versus time. Okay. Yeah, we don't have to go through all the details. Okay, so then the main result. So first there's a calibration curve where you look at the angle of the polarization rotation versus the sucrose concentration. In principle, this should be linear. It looks like the data is maybe not so perfect, but it is what it is. Okay, and then let's see what's next. There should be some time data. Oh, okay, that's included here. So basically, they measured polarization versus time, and they report that in the form of a graph. And then in the data analysis section, they explain how they analyzed the data, how they obtained the rate constants, what calculations they did. They include the optimized values that they obtained. So this is a nice graph as a function of iteration number to see whether there were any outliers. And then they include the final fit result, comparing fitting the measured data using a 0th order approximation or a 1st order kinetics approximation. Okay, then in the conclusion section, they give the main conclusions. So they conclude the reaction mechanism is most likely 2nd order due to the results obtained here. And they give the final rate constants and alpha infinity values. And then there's a reference section, right? So each reference is given, and there should be an appendix at the end, but that was not included. So 5 points were deducted. Okay, any questions about this? Questions from the Zoom? Where's the, maybe I have to go to Zoom to see whether anyone's posted a question. Okay, maybe I have to stop share. Okay, I don't see anything in the chat, so I assume that there's no questions. Okay, let me go back to the presentation. Okay, so writing with a good scientific style can really help improve the clarity and precision with which you present the information, which is very important because you want people to be able to read about what you did and understand it in the most efficient way. So let me get my laser pointer back. Okay, so I'll talk a little bit about basic guidelines for scientific writing. So what is the goal? The goal is to communicate to other people what you did, why you did it, and what you found out, right? Because if you do a science experiment in your basement and then never report the results, then I would argue you might as well never have done it, right? Because you're not benefiting the rest of the world by reporting what you did. You want to write in standard English, avoid slang terms. In formal writing, there are some rules. For example, you don't use contractions in formal scientific writing. So for example, you wouldn't use the word can't. You want to spell out the word cannot. Okay. In scientific writing, often it is efficient to use abbreviations and acronyms, but you always have to define these abbreviations and acronyms for the reader. Otherwise, if they're not intimately familiar with a certain area of science, they're going to be totally lost. Okay, so for example, if you're using a flame ionization detector, maybe you want to use the abbreviation FID, but the first time that you introduce the concept, you need to write out the name of the technique that you're using. So a calibrated flame ionization detector, and then in parentheses, you can write FID, was used to determine the molar concentration. And then subsequently, if you refer to this technique again, you can just refer to it by its abbreviation FID. And so, by the way, you don't have to include, you don't have to define every single abbreviation if it's something that's universally accepted. So for example, the abbreviations for SI units that are given here, those are universally known. You don't have to say L stands for liter in this case. Okay. Okay. Like we saw in the example journal article lab report, you need to refer to all of the figures and tables in the main text. Otherwise, you're just shoving a figure in the reader's face and not telling him, why he's looking at this figure. So, if you're going to include a figure, you need to have a sentence in the main text somehow referring to that figure. So for example, you would have a sentence saying something like figure 2 shows a comparison of the data to the theoretical prediction of equation 3. Okay. You need to have a caption for each figure where you explain what is plotted. And if the information is not available in a legend, in a plot legend, then you need to include specific information about how to understand the figure. So for example, you want to include in the figure caption information like, black markers represent the measured data and the dotted line represents the least squares linear fit. Okay. And so another point when writing is you always want to make sure that you are using precise language, that you're really saying exactly, literally what you mean. It's because quite often when you're writing about science, science is complex and it's difficult to write about, and it can be even more difficult to understand. So when you're going through editing what you've written, make sure that your sentences are really literally saying what you want them to say. So an example of a sentence that one of my students wrote, they were doing a surface science experiment, and they said, they wrote, the sample is heated by resistive heating and is switched off before the laser shoots. Okay, so literally if you read the sentence, it would say that the sample is switched off before the laser shoots. But that's not actually what they meant to say. They meant to say that the resistive heating was switched off before the laser shoots. So make sure that you word the sentence in a way that's clear, that that's what you mean. So it would be better to write, the sample is resistively heated and the heating current is switched off before the laser fires. Right? This is a more objective and precise way to explain what you did in the experiment. Maybe one other topic that I'll mention here, I didn't put this in the presentation, but another trap that students often fall into is, I think sometimes you're taught when you're learning about writing not to be too repetitive. And so it's tempting to try to come up with synonyms for words in order not to repeat yourself. But actually in scientific technical writing, the most important thing is to choose the right word, to choose the most precise word for what you want to describe. So, for example, if you're writing a whole lab report about the inversion of sucrose, you're probably going to use the word sucrose many times. And if you write in one sentence, we did something to the sucrose sample, and then in the next sentence, you try to find a synonym for sucrose. So maybe you call it sugar. That's actually a very imprecise way to write, because sugar could refer to any monosaccharide or disaccharide, right? It could also refer to fructose or glucose, for example. So you want to make sure that you're really using the precise and correct words, and don't worry too much about repeating a certain word. Okay. Another topic that comes up in scientific writing is the use of the passive versus the active voice. So there is a preference in modern writing to use the active voice as much as possible, especially in the humanities fields. This is very, very strongly preferred. So what do I mean by active versus passive? So an active sentence is when you have a subject and it does a certain verb to the object, right? So for example, the student aced her exam. The subject is the student, the verb is to ace, and the object is the exam. Whereas in a passive sentence, you put the emphasis on the object and you say a certain thing was done by a certain subject, right? So in this case, if you wanted to rewrite this sentence in the passive voice, you would say the exam was aced by the student. And in this particular example, the passive voice sounds really clunky and not very elegant. And so there's a strong preference to use the active voice. So when possible in scientific writing, we try to use active voice and also choose a strong verb. So here's an example from something that I was editing, trying to improve. One of my students wrote, "The gas sample can be let into the chamber by an inlet valve." So there's nothing wrong with this sentence. I don't think your TA would take off any points for this, but you can write this better. You could say, so this is basically a passive sentence because basically it leaves out the subject, right? The person letting the gas sample in, and it just says the gas sample, which is the object, it can be let into the chamber by an inlet valve. But it's better to make the sentence active by writing the gas sample enters the chamber through an inlet valve. This has a nice strong verb enter, and so the emphasis stays on the thing that you're looking at, the gas sample, and you just rewrite it to make it more active. Okay, so in technical scientific writing, the passive voice is actually acceptable, and it is actually used quite a bit. So that's a difference between science and humanities, is that scientists do use the passive voice. And often the reason why you do this is because when you're writing about science, the emphasis is on the system that you're looking at and not necessarily, the people studying that system, right? So often we use passive voice in order to avoid saying exactly who did an experiment and just focus on the experiment itself. Sometimes we also use first person in order to do that. And so I'll give you an example. So let's say you did an experiment and you were writing the procedure section. Okay, so if you are just super duper literal, you might write, okay, Sally opened the gas valve while she May entered the equilibrium pressure into the lab notebook. Okay, but this is stupid because this is too much information, too much personal information, right? Nobody needs to know who did exactly what part of the experiment in order to be able to reproduce your results. So one way to get around that is by using first person. So you can say, we opened the gas valve and recorded the equilibrium pressure. Or it's also acceptable to write the sentence in passive voice. In other words, to write, the gas was introduced into the chamber and the resulting equilibrium pressure was measured. This is also acceptable. Okay, any questions before we move on? I don't see any, so let's move on. Okay, I think this is the last topic that I wanted to talk about writing styles. So another thing that can be a little bit confusing if you're not used to writing in a journal article style is, what tense should I be writing in, right? So you want to, in general, avoid shifting tenses frequently, right, from one sentence to the next within a paragraph. But the tense in scientific writing can change from section to section, and sometimes you can have mixed tenses. So, for example, in the introduction, most typically you would have a mixture of present tense and past tense. So if you give background information about previous work or historical information about a certain field that you're describing, then you might want to use past tense. But if you're presenting facts that are generally true about the topic that you're presenting, then you can use present tense. So for example, calorimetry is a common technique for precise measurement of reaction enthalpies, right? This sentence is in present tense because it's sort of general information about calorimetry. But then you go to give some historical perspective and you switch to past tense. So the first calorimeter was developed by Lavoisier in 1780, etc. And note, this is also an example of a use of passive voice in this sentence, right? Because the emphasis is on the technique and not necessarily on the person doing it, okay? In the procedure section, most of the sentences should just be in simple past tense. You want to just explain what you did in the lab as you were carrying out the experiment. So for example, the sample was obtained from Sigma Aldrich and was used without further purification. In most of these experiments, you're using some kind of instrument. So you would then maybe want to say we loaded the sample into a Carry 3000 UV vis spectrometer and measured the absorption spectrum or something like that, right? So these are all simple past tense sentences. Okay, and then finally, the results and conclusion section. Maybe when you're presenting a final conclusion, it's appropriate to put a sentence in past tense. We obtained a value of X, but if you're writing conclusions that are generally true, then you should use present tense. So the results agree with the theoretical prediction to within the experimental error. You want to use present tense here because this sentence was true yesterday, it's true today, and it's presumably still going to be accepted as true in the future. Okay, any questions? About either lab reports or anything else in the course? Okay, seeing none, that is the end of the material that I wanted to cover. So I wish you all the very best of luck in all of your laboratory experiments that you do throughout the semester. You're going to start seeing a lot less of me and a lot more of your TAs from now on. Yeah, the lab experiments start next week. So thank you all. I'm going to let you go a bit early and have a nice evening. Oh, there are something in the chat. Oh, okay. Thank you. Okay. Yeah. Thank you. Have a good evening. Yeah, you too.